Now let us discuss next topic, that is oscillations and waves. So this chapter has been divided into two. One is oscillations and then the next thing is waves. So first let us study all the things, all the concepts that are related to oscillations, and then let us move to waves. So here we might have studied all this in your lower classes also. So the definition of periodic motion, what is the meaning of time period, and then what is oscillatory motion, what is to and fro motion, all that we might have studied in our lower classes, but still we'll just have a quick revision of those definitions here. So the first thing is periodic motion. So as we all know, motion which repeats itself at regular intervals of time, that motion is called as a periodic motion. Example is motion of earth around the sun. So that will take 365 days to complete one revolution. So after every 365 days it will be completing a revolution, and the time period is basically 365 days. So periodic motion is basically a motion which repeats itself at regular intervals of time. At regular intervals of time. And then what is a time period here? Time period, when we tell periodic motion, we define some terms like time period, frequency, all those parameters. Now what is the meaning of time period? Time period means the smallest time after which it repeats its a cycle. So time period can be denoted as, or it can be denoted as capital T, and this we have already studied in circular motion also. Time period, time taken by the particle to complete one full circle or one revolution or one crest and one trough. So time period is nothing but basically the smallest time after which the motion repeats itself. Smallest time after which the motion repeats. So this will be called as the time period. Now what is the definition? How do we find a time period? So we know when a particle is moving in, say, circular path, with constant speed, so with say omega, let the omega be the constant speed. So we know omega is equal to theta by t. Now in one full circle, in one time period means, suppose for example if the particle starts say at point A, it has to complete a full circle. So the time taken by the particle to complete one full circle or one revolution or one oscillation or one to and fro motion, that will be called as time period. So how much distance it travels? 2 pi r it travels, or in terms of angle if I write, it will cover a complete angle of 2 pi radian. So it will complete an angle of 360 degree in full revolution, or we can also write it as 2 pi radian because the SI unit for theta is a radians. So it will be 2 pi radians divided by time. Time will be what? When it traces an angle of 2 pi, it has completed one full time period, it has completed one full circle, and the time taken to complete one full circle only is called as the time period here. So you can write T as capital T. So this will be capital T. So we get one important relation between omega and T, that is T is equal to T will go this side and omega will come this side. So T is equal to 2 pi by omega. So one of the important relations which we have also studied in circular motion. Now one more parameter that comes in periodic motion is the frequency. Is basically what? Frequency is the reciprocal of time period. So what do we define frequency? Time period is nothing but the time taken by the particle to complete one full circle, so one complete oscillation. Frequency is nothing but the number of oscillations made by the particle in 1 second, that will be called as frequency. So the definition of frequency is the number of oscillations made by the particle, made or completed by the particle in 1 second or in a unit time, in 1 second, that will be called as what? That will be called as frequency. Now how is frequency reciprocal of time period? Let us see here. So what is time period? Time taken by the particle to complete one revolution. So for one revolution, it will take how much time? It will take a time of capital T. Now what is frequency? The number of oscillations made by the particle in 1 second. So if I call F is nothing but, F is what? Number of oscillations made by the particle in 1 second. So here I am writing basically time, and here I'm writing number of cycles. So if I use the unitary method here, so one cycle is completed in a time of capital T. So F number of cycles, number of oscillations, or number of, basically I can also call number of cycles, all are same. So F oscillations are made in how many seconds? The number of oscillations made by the particle in 1 second. So that number of oscillations made in 1 second will be called as the frequency. So cross multiply, what you get? 1 into 1 is 1, that is equal to F into T. So I get F is equal to 1 divided by T. And what is the unit of a frequency? The unit of frequency, SI unit, is hertz, or you can also call it, since it is number of cycles made per second, it can be also called as cycles per second, that is CPS. So from here I can get F is equal to what? F is equal to 1 by T, 1 upon T. So if I use the relation, what is the relation? Omega is equal to 2 pi by T. Omega is equal to 2 pi by T from the previous result. 1 by T is also equal to F. So that can also be written as 2 pi into F. So a very standard and important result in oscillations, that is omega is equal to 2 pi by T, or that can also be written as 2 pi F, because reciprocal of time period is nothing but the frequency. So this is all about periodic motion. Now, what is oscillatory motion? What is oscillatory motion? Oscillatory motion is also no doubt a periodic motion, but in this the particle will be oscillating about a fixed point. That is, our particle will be moving to and fro. It will be describing to and fro motion. So oscillatory motion is basically, we know it is to and fro motion. In oscillatory motion, the particle oscillates to and fro, towards the right and towards left. It will keep on oscillating to and fro about a fixed point, about a fixed position or fixed point, which is called as the mean position, Now what is the example for this? Example for this is, if I take the pendulum which is hanging on a wall clock, or if I see the oscillations of a pendulum bob, so what will happen? So if this is a pendulum bob, if it is given a small jerk, what will happen? It will go to the right extreme and then it will keep on oscillating like this. So the pendulum bob will keep on oscillating. So you can see that if I just map this motion along a straight line, if I just map it, so this is the fixed point, that is the mean position. The fixed point is called as the mean position. We will discuss about mean position later further. Now here the particle is keep on oscillating about this point. It is going towards the right and it is going towards left. That is, it is oscillating to and fro. It is performing to and fro motion. So oscillatory motion means, basically in this a particle will be oscillating to and fro about a fixed position. So the two ends up to which it can go, the maximum extremes, those positions are called as the extreme positions. Those are called as what? Extreme positions. Suppose for example, if it is describing, if the pendulum bob is describing, say, a maximum angular displacement is theta, then this will be the extreme position of the pendulum bob. Beyond this it cannot go. It is oscillating in this fashion about a fixed point. That fixed point will be called as the mean position, and the two ends up to which the particle can travel, those are called as the extreme position. One along the positive side, one towards the right of the mean position, and one towards the left of the mean position. So there will be two extreme positions. One can be taken as positive and one can be taken as a left end, that is a negative extreme. So here in this we define one important term called as the amplitude. Amplitude is denoted by A. We have already studied what is time period. We have already studied what is frequency. What is the relation between time period and frequency? Now let us see what is amplitude. The third definition. Amplitude is nothing but the maximum displacement of the particle when it is describing an oscillatory motion, that is when it is describing to and fro motion from the mean position, that will be called as amplitude. So amplitude is nothing but the maximum displacement of the particle, from the mean position. You have to be very careful that it is with respect to the mean position only of the particle from the mean, or it is also called as the equilibrium position, so that will be called as the amplitude A, denoted by A. So since it can go only up to this end. If it comes back after here, then this will be the amplitude. in the positive side plus a, and this is the maximum end or maximum extreme up to which the particle can travel in the negative direction or towards the left of the mean position, that will be called as the minus a. And you have to be very careful that this displacement can be linear or angular also. It can be what? It can be linear or it can be even angular displacement. So here if I consider a pendulum bob, what will it be? Since it is describing, it is generating some angle theta with respect to the vertical. So if this is the maximum position up to which the bob can go, after which it will fall, it will come back to the mean position. So this is the maximum angular displacement. It can be anything, 30 degree, 40 degree, 50 degree. It can be anything depending upon the conditions what we have. So the maximum displacement of the particle from the mean position, that will be called as the amplitude. So how is that? So it is measured from the mean position to the extreme position. That will be called as the amplitude. So it will be equal to x equal to a, and this will be equal to how much? X equal to minus a, or I can also call here the angular displacement will be equal to theta. So this is basically an oscillatory motion. All oscillatory motions, no doubt they are periodic. Why they are periodic? What is the definition of periodic motion? A motion which repeats itself at regular intervals of time. In this case also pendulum is it is oscillating. No doubt it is performing the same motion again and again, so it is repeating itself. The pattern what it is generated is being repeated. So oscillatory motion, no doubt it is periodic motion, correct, but not all periodic motions are oscillatory. For example, a particle which is moving in a circular path, no doubt it is periodic, but it is not oscillatory. Why it is not oscillatory? It is not oscillatory because the condition for oscillatory motion is it should be moving to and fro about a fixed position. It is not moving to and fro. It is moving in a circular path. It is just rotating. It is not moving to and fro. So we can tell that all oscillatory motions are no doubt periodic because they are repeating itself after regular intervals of time, but all periodic motions are not oscillatory. Now, one special kind of oscillatory motion is simple harmonic motion, which the analysis of which mathematical analysis we will do now.